All right, one place parametrics are used is with position vectors. So if you have a vector where there's a x that depends on your parameter of t and a y, that's going to show your horizontal and vertical movement. So on our picture down here, your x of t would give you your horizontal distance. The y of t would give your vertical distance, and then when you combine those, you get your position vector right here. And so that's a place where parametrics are used a lot. Also, then from our work with derivatives, we know if we would take the derivative of both of those, that would be our velocity vector showing the horizontal velocity and the vertical velocity. And if you did the second derivative, you would get your acceleration vector, your horizontal acceleration and your vertical acceleration. Some things to know. If you take the first derivative, you're getting this velocity vector. If the x component of that is positive, greater than 0, that means the object's direction is going to be to the right. If it's less than 0 or negative, then your object's direction is going to be moving to the left. So the positive negative indicates direction. Similar with the y part of it, if the y is positive, greater than 0, then you're going to be moving up. If the y part of the velocity is less than 0 or negative, that means you are moving downwards in direction. When a velocity and acceleration are both positive or both negative, then the object is speeding up. So if they are moving in the same direction, you have something that's speeding up. When the velocity and acceleration have opposite signs, so one is positive and the other one's negative, then the object is slowing down because they're working against each other. Anytime the acceleration would be 0, then the velocity is constant. One last thing to know before we attempt some of these problems, you can find the position of a parametric if the starting position at time t1 is shown as this, and you want to find where is it at time 2, we can do that by using fundamental theorem of calculus, kind of that twist on it. So recall again, if you take an integral here and we're integrating the x component of the velocity, because remember derivative here would be velocity from time 1 to time 2, the antiderivative of that would be just the position at t of 2 minus the position at t1. So now if we just manipulate this a little bit and add over our t of x at t of 1 here to the other side, you get this statement shown here. So it's just kind of using that twist. And same can be done with y as well. So if you want to find a later position, take your starting position plus your change in position, and that would give you your ending position.